Hello and welcome. In this video tutorial, I want to go over the trigonometric ratios sine, cosine, and tangent. Given an angle of reference, these functions specify the ratios of certain sides of a right triangle. For instance, we can have the angle theta, or we can have the angle beta. We will not be using the 90-degree angle as an angle of reference. Now, I will illustrate the definitions of sine, cosine, and tangent by using the angle theta. The first thing that I'm going to do is I am going to label the triangle. The length that's across the angle of reference, in this case that's theta, that's going to be called the opposite side. The length that's across the 90-degree angle, that's going to be called the hypotenuse. The hypotenuse is the longest side on the right triangle. The remaining length, we're going to call that the adjacent side. Now, if we want to get the sine of theta, we have to get the opposite side and divide it by the hypotenuse. That's the definition of sine. By definition, cosine would be the adjacent side divided by the hypotenuse. And finally, the tangent would be the opposite side divided by the adjacent. These are the definitions of sine, cosine, and tangent. You will use your angle of reference. The following mnemonic device, SOHCAHTOA, will help us to remember which two lengths are needed in order to use each trigonometric function. For example, sine, by definition, is the ratio of opposite over hypotenuse. Cosine, by definition, is the ratio of adjacent divided by the hypotenuse, and tangent, by definition, is the ratio of opposite divided by the adjacent. Let's look at an example. So here it says, set up the trigonometric ratios for sine theta, cosine theta, and tangent theta. Theta is our angle of reference. So the first thing that I need to do is to label this triangle. And recall that the length that's across theta, that's going to be called your opposite side. The length that's across your 90-degree angle, that's going to be called your hypotenuse. And the remaining side is going to be labeled as the adjacent side. Now I'm going to use my mnemonic device, SOHCAHTOA, so that I can write the ratios for sine, cosine, and tangent. Beginning with sine, the ratio for sine of theta is going to be the opposite side divided by the hypotenuse. So that's going to be 15 divided by 17. Next, I'm going to get cosine. So cosine of theta, that's going to be the ratio of the adjacent side divided by the hypotenuse. That is 8 divided by 17. And finally, I'm going to get tangent. So tangent of theta, by definition, is the ratio of opposite over adjacent. That is 15 divided by 8. Let's look at one more example. So example 2, we have to set up the trigonometric ratios for sine of beta, cosine of beta, and tangent of beta. So this time the angle of reference is going to be beta. But we will apply the same principle. Using our angle of reference, the length that's across will be labeled as the opposite side. The length that's across 90 degrees is going to be called the hypotenuse. And that leaves the remaining side to be called the adjacent side. Now we're going to set up the ratios for beta. So beginning with sine of beta, we have to get the opposite and divided by the hypotenuse. So we're going to get 15 and divided by 25. Now notice here that the 15 and the 25 have a greatest common factor of 5. So this is going to reduce to 3 over 5. And now we're going to get the cosine of beta. And by definition, that's going to be the adjacent side divided by the hypotenuse. So we're going to get 20 and divide it by 25. 20 and 25 also have a greatest common factor of 5, so we can reduce the 20 over 25 into a 4 over 5. Finally, we're going to get tangent of beta. And by definition, tangent is the opposite divided by the adjacent, so we're going to get 15 and divided by 20. 15 and 20 share a greatest common factor of 5, so we can reduce this to 3 over 4. And those would be the ratios for beta.